All right, so let's kind of look at the other side here. A drug manufacturer tests a particular drug to see if it benefits patients with a particular symptom. The table shows the results of the study. Okay. So I'm going to use function notation to communicate my steps, and in exams or if in quizzes, I want you to do the same. So use function notation to communicate what you're doing. Okay. So just like I've been doing here, notice when I've been trying to communicate what I'm doing, I'm using function notation. This terminology is expressed in function notation. So again, what is the probability that a person felt relief from the symptoms? So this question is just about felt relief. So I'm just going to call relief. And the chance from the study that a person felt relief, well, 1,000 people felt relief. This is my sample space. This question is about everybody in the sample space. So this is 1,000 divided by 10,000, which is 0.1. So about 10% of the population, 10% chance people felt relief from this study. Okay. So now we have this one. If a person is in the age group 20 to 35, notice this is saying, let's change it up a bit. Before it was, what's the probability that a person felt relief? I'm assuming it has to come from everybody. But this one now gives you a condition. This is a condition. In other words, this is a given. This notation that we're using is called conditional probability. So now the condition is if a person is in the age group 20 to 35, okay. So in other words, this is now the given, the 20 to 35. What is the probability that they felt relief from the symptoms? So the question is still about relief, but in this age group. So, oh, okay, so I'm not talking about the whole 10,000. I'm talking about 20 to 35. So 20 to 35, well, this is now the only thing I'm considering. The group 20 to 35. I'm not considering anything else. So that population now consists of only 5,000, of which only 400 felt relief. So in the age group 20 to 35, only 400 felt relief. So now, if I were to calculate this, it give me 0.08. Okay, so 8% of the population felt relief. So how does that compare to the population as a whole? Well, notice the probability went down. So basically, the age group 20 to 35 years of age less relief compared to the population. So notice, are the two events independent then? So that's all that means. They're definitely not independent. Why? Because notice, the regular population is 10%. The 10% of the population feels relief. But when you're looking at this age group, The proportion that felt relief is only 8%. So it went down. So this group did not feel as much relief as the general population. So as far as the medical concern, it goes, well, potentially it doesn't work as good for this age group, right? Maybe. So of the people in the age group 51 or older, what proportion felt relief after taking the drug? So notice again, of the people in the age group 51 or older. So again, notice condition. We're not talking about everybody. We're talking about a particular group of the people in the age group 51 or older. And the question is, what proportion felt relief? So again, we're not talking about everybody, just the people in that age group. So what the question is talking about is concentrate only on 51 or older. And what I want again is relief. So now I'm only looking at this part of the table. Only. And there's only now 2,000 people that I'm dealing with. And then the ones that felt relief is this group. $200. And notice when I reduce that down, what do I get? Yep, 1/10 or 0.01. Exactly, 1/10. So how does that compare to the population as a whole? The 51 plus age group felt the same relief as the population as a whole. Okay. So what does that mean about independence then? Yeah. Yep. So exactly. So being 51 plus, uh, getting relief, are independent events. That's the meaning of it. So are we good so far? Okay, good. So let's kind of finish up with these two questions. Are the events a person is in the age group 36 to 50? A person felt no change, independent events. So suppose that's the question. Are they independent? I need you to show that. So at that point, what do I need to do? It doesn't matter how you work it. I'm going to work it this way. I'm going to go felt no change. So I'm going to go no change. So I have to take one of them. Does it matter which one you take? It doesn't really matter. Okay, if I want to show independence, I just need to grab one of them and find it in terms of the population. So I'm going to just find no change first. So what's the chance of no change? So no change means that uh, here's the group that felt no change, but in that question is based on the whole population. There's no condition. Notice the question here has no condition. So it looks like it's going to be 3,000 over 10,000. Okay. So it should come out to, again, 30%. I'm hoping if I do this right. Okay. But now that I've done this, okay, so this is the thing so it doesn't really matter. But once I've done this, the next question I have to ask, if I want to show depends are independent or not, now, because I did this, I'm forced to ask this question now. Notice it's the same question, but now based on a condition. The condition now is the other event. So given that you're 36 to 50, what's the chance of no change? So when I look at the table, there's only 3,000 in that group, and 800 have no change. So when I divide this out, I get 0.26, and then it continues 0.260. So again, notice no, events are not independent. Right? These two numbers are not the same, so we don't have independence. Again, since we've been doing hypothesis tests, how will we do this in a real life situation? The way you would do it is using data that all of a sudden you would have a sampling distribution of this difference between the groups, and you would run a hypothesis test, or you could run a confidence interval to try and figure out if there's enough separation between these two numbers to determine if there's independence or not. Okay. So right now we're using exactness, which is probability theory, but statistics is saying we actually don't know the mechanisms. We're only getting from data. From data, we would have to run some kind of test to figure out if these numbers are close enough. One more. Are the events a person is 26, 30, 50 age group, a person felt my relief, independent events? Okay, so I'm going to switch it up a little bit because I've been doing it this way. So I'm going to just do the age group first. I mean, this doesn't quite make sense from the perspective of medical, but I'm going to do it just to prove a point. So I decided to grab this group. What's the chance of being 36 to 50? Well, there's 3,000 people that were 36 to 50 out of 10,000. Excuse me. So again, that's 0.3. Okay. Now, what's the chance of it being 36 to 50? So since I chose this as my starting point, I need to use that. Yes. Let me back it up a little bit. So right now, the first question is being in the age group 36 to 50, right? So there's 3,000 people that were 36 to 50. But the question is about the entire sample space. So it's going to be this over this because there's no condition placed here. Okay. What about 36? Now, once I chose this, the next question has to be 36 to 50, mild relief. So I'm going to go mild R, mild relief. And if I did that, now mild relief is my whole. So I need to figure out the mild relief, which is 6,000. So now I'm only looking at mild relief. Mild relief is right here. That's my new reality. Only mild relief. But what I'm after is in the age group 36 to 50. So there's only 1,800 that felt mild relief in the 36 to 50 group. So that's what goes on top. I take this number, 1,800, divide this by 6,000, and I get 0.3. Same thing. So are the two events independent? Yeah, the two events are independent. Okay, that's all it means. In other words, the probabilities have not been changing for these two groups. And notice, just to prove the point, had I switched this around, so I don't need to go any further. I have proven that two events are independent. I'm just doing this to show you that had you chosen the other way around, things would have come out exactly the same, meaning same conclusion, not same numbers. So if I chose, okay, mild relief as my starting point, mild relief is, when I look at it, there's again 10,000 is my whole population, and my relief is 6,000. So that's 0.6, right? So my relief, there was 6,000 out of the whole population that felt my relief. The next question that would be, same question, mild relief. So now I'm going to use, oh, I'm sorry, I need to put the other event, mild relief given 3650. The age group 3650. So now I'm only dealing with the age group 3650, which has only 3,000 people, of which 1,800 had the mild relief. So if I calculate that, I know it's got to come out to 0.6. How do I know it has to come out 0.6? Because I already know the events are independent. But if you tried it, it's going to come out to 0.6. So notice, it's not that the numbers come out the same when you reverse, it's just that you come up to the same conclusion. The events are independent. So in other words, this group does exactly the same as the population. There's nothing different about it.